900,000 years ago, the human race almost went extinct. Now, you might have seen this as a news headline in the last couple of years. Evidence from genomic research indicates that close to 900,000 years ago, our species plummeted into a near extinction event with a loss of around 98% of genetic diversity in a very rapid period. So if you look at the chart here, you can see that we had almost 100,000 breeding individuals present in the world a million years ago. And then around about 930,000 years ago, there is this event where suddenly the population seems to plummet, and we are left with just 1,280 breeding individuals. So there are other people alive, but they are not contributing genetic information to future generations. So they may be either just incapable of that, or elderly, or don't find a partner. So we're not talking about the entire population of the world, but this is the breeding population. Now, a bottleneck is where you have a sudden narrowing, and then of course it will expand back out. And you can see that in the chart here. You can see that there is this very, very rapid decrease from almost 100,000 down to less than 1,300, and then the population stays at this kind of level for almost 120,000 years. So they've got it's 117,000 years approximately. That's quite amazing because you think, that we managed to kind of hold on for that period, because that's actually quite a long time to have such a small population. So, but somehow they do cling to life. And of course, we're here because of it. Then at around about 820,000 years ago, there is a sudden expansion in the population size with a return to a much more significant number, but not the original kind of population size. But we have about 27,160 individuals who are now interbreeding. And that happens in, very quick succession. If we look at the chart, we can see that it's bang, drop, long, narrow bottleneck, and then bang, a sudden resurgence to larger population. All very strange. That's not a gradual dying off and a gradual return. So there's something very strange is happening. The current mainstream hypothesis is, assuming that this is a real signature, is that the climate may well have played a role, that there was some climatic events underway at the beginning of this, in this period that we're looking at, and adverse to humans. But even then, it doesn't seem to explain this. And again, there's fossil sites around the world suggesting that humans are present around the world. There's not a very obvious correlation in the archaeological record with a sudden, say, disappearance of the global population. So how do we interpret this? If it is not a cataclysm that has killed off most people on the planet, what's another way that we could explain this drastic bottleneck event? I'm going to do that for you right now. There is another interpretation to this chart, and that would be that around about 930,000 years ago or thereabouts, a group of humans breaks away from the larger population and becomes regionally isolated. They are no longer able to interbreed with the rest of the humans on the planet. So those other humans have not gone anywhere. They are still out there. There is a region where this could have happened. And again, we've got the dates here are very interesting because around 1 million years ago, we find evidence of hominins on the islands across Southeast Asia. We know that humans have crossed the Wallace's Line, which is the once thought sort of impenetrable barrier for mammals across into the islands of Southeast Asia and Australia. We know that they have crossed. And so we have fossils on Flores, and more recently, there's evidence also on Sulawesi of over 1 million years ago. So we know that hominins have breached Wallace's Line. They must be using watercraft, so simple, small boats. Probably just, could even do with logs, but probably something like bamboo, knotted together with reeds, anything like that would do this. So they've managed to construct viable watercraft, and they've crossed the islands. That would cut them off from the larger population in Southeast Asia, and of course connecting to East Asia and Eurasia, that, there is a larger population out there, but they would be cut off. Now, if these are our true ancestors, this group of hominins in Southeast Asia, This would fit very nicely because we can imagine a splinter population of around, let's say, 1,300 breeding pairs and some other people that didn't breed who have moved across these islands, potentially reaching Papua and Australia, and that they may be living across several of these islands and mainland Australia, isolated from the rest of the world and only mixing within their own kind of maritime kind of society. This would explain this drop. The other thing that we can explain with this model is the sudden return to a larger population size. Because, of course, usually as a population expands through breeding and reproduction, there'd be a gradual increase and then perhaps accelerate over time. But what we have here is not that. It is a sudden restoration of population size from 1,300 odd people to almost 28,000 very suddenly at close to 800,000 years ago. We can explain that if we imagine that this population then comes under pressure to return to Southeast Asia and there's a migration back into the mainland, that these people will then encounter other humans who are still out there. And so they will begin to very rapidly increase in genetic diversity because they're breeding with all the people that are still out there. You still have higher diversity as well. And so we will have evidence for a much larger population very quickly, right? And that's precisely what we see in this chart. Now, there's some other interesting things I want to go into because around 800,000 years ago, there's some really intriguing things underway. First of all, we have a geomagnetic reversal, the last geomagnetic reversal. So this is a complete inversion of the north and south magnetic fields of the planet. So this was underway for a few millennia. It wasn't a one-day event. It takes a few millennia, but we know that this event centers on around about 790,000 years ago, obviously a few thousand years either side. And there are effects on humans from this. That is that radiation that is usually kept at the higher altitudes is making its way down to the surface. So the natural defenses of the Earth are down. The fields are very low in strength during a reversal. This can cause DNA damage and could cause some loss of the number of humans that are around the planet. And that would fit with this reduction we see here, that there's no longer a global population involving at least 100,000 interbreeding individuals. There's only 27,000 or so, right? So there's a suggestion there that there has been a crash in real terms for the larger population during this period of isolation associated with the bottleneck. There's also another thing that's happened here, which may conflict with that or may better explain this kind of anomaly as to why they don't recover to the full population size. And that's that we can see here on the chart, there is a chromosome fusion event dated very closely to the time of the bottleneck. Now, this fusion event is quite intriguing because we have an end-to-end telomeric fusion. And these are very rare. I mean, they are seen in a handful of creatures on Earth, but they are very rare. And this one occurs right in the middle of this bottleneck. In this very small population, we get a sudden end-to-end fusion event. And that times with not only, of course, this strange population change and also the fact that we have a magnetic reversal going on, all these other things. But this also times with the sudden split from Homo erectus or Super Archaics for the ancestors of Neanderthals, Denisovans, and us. And some people call that initial population Neandersovans. That we have a population that lives close to 800,000 years ago that is separate from all the other earlier archaic populations and will very quickly evolve into these other large-brained populations, so Neanderthals, Denisovans, and us. That occurs during a period of time, approximately 800,000 to 700,000 years ago, that we have this splintering going on. In fact, you can kind of see that in the background behind me. If you have bring that up so you can have a better look. But you can see here that this is when we get the divergence event from the Super Archaics. It takes a little while to fully happen, but by about 750 to 700,000 years ago, these populations have diverged, and we now have the beginnings of these distinct large-brained human groups. Now, the thing is, all three of these, the Neanderthals, the Denisovans, and modern humans, they all have the fused chromosome 2. So we know they come out of this population that has split away. We also know that the best evidence for where the Denisovan homelands are is now pointing towards Papua and in that region. That's where we see the strongest signature of Denisovan DNA in modern humans anywhere on the planet by far. In fact, there's indications that there may have been 3 different populations of Denisovans that have given genetic information to modern Papuans. So it really seems as though this was the lands of the Denisovans. When you start putting all these things together, of course, you get a lot of hand in glove fit. And so the other thing we have to look at is that, what does this fusion event kind of do? And there is the potential, and it's giving us some kind of extreme benefits. Because keep in mind, there is a total replacement, that this one should be problematic mutation goes on to stabilizing the entire population of modern humans, Neanderthals and Denisovans. So clearly it is even neutral or very beneficial. And it looks like it's very beneficial because of the way it just spreads and becomes ubiquitous. And it not only is ubiquitous in these 3 groups, eventually all the humans on the planet that remain have the fused chromosome. So everyone else is basically outcompeted or outbred or bred into this group, that we end up with an entire global population with the chromosome 2 fusion. So this is really marking a point where a lot of anthropologists are actually suspecting this is a speciation event, that a new species is coming out of this bottleneck and out of this divergence, out of this chromosome 2, and it's really the true beginnings of Homo sapiens. And in fact, you can say with Homo sapiens, you could incorporate Neanderthals and Denisovans in that, as many anthropologists do. They see these are all Homo sapiens populations coming out of this singular event, and that they just live in regionally distinct areas and only mix occasionally over the next hundreds of thousands of years. But they can still mix, and they still have the fundamental changes that occurred 800,000 years ago. They're closely related populations. So I think that this answers the mystery. It tells us kind of what really happened. I don't think there's any global cataclysm that has wiped out everyone. I think that this is a bottleneck due to an isolation of our ancestors, and that it's at that same time that we get this crucial change at the genomic level, which is occurring right as we have this, this sudden kind of reversal, relatively sudden reversal underway. All of these things are coming together in this actually spectacular series of events that leads to us. And here we are seeing the evidence right in front of us, but it's being misinterpreted by many mainstream scholars as being a potential mysterious cataclysm, although they cannot find any evidence of such a cataclysm. Thank you very much. Hopefully that was interesting, and I will deep dive into more of this story in other videos.